Okay, let's work an example of a plant growth regulator calculation. We'll do a few of these and I'll post them on the website. Again, you've got a few in the notes, but this will be additional examples and help you out. So let's say we're looking at using the plant growth regulator bonsai. And we have the label here for bonsai. I've just printed one off. This would also be on the bottle, or you can print it off on the web. Two things I want to point out to you. First of all, bonsai is a commercial name. And the active ingredient in bonsai is paclobutrazole. So anytime we're a little sloppy in our language because we often say we want a 200 ppm or 100 ppm, or a 20 ppm solution of bonsai. What we mean is we want a 20 ppm solution of the active ingredient in that chemical. What's in this bottle, all of what's in this bottle is not active ingredient. In fact, very little of it is. It's water and emulsifying agents and things like that. So just remember, when we're doing growth regulators and we're doing a ppm thing, we implicitly mean we want a certain concentration of the active ingredient. So if we say that we want a 15 part per million bonsai solution, what we mean is we want a solution using bonsai that would contain 15 parts per million of the active ingredient, or would contain 15 parts per million, in this case, the active ingredient being paclobutrazole. And as you look at this, how much of this, just like fertilizers, we looked at the percent nitrogen by weight to do calculations, we need to know that here. So bonsai is actually, off the label here, 0.4%. And a lot of our regulators, growth regulating chemicals, instead of giving you a weight basis like our fertilizers, we're dealing with this thing as a percentage now, if it's a liquid growth regulator. So that's something we haven't really dealt with because our ppm calculations, remember, are milligrams per liter, so we could just do the weight. But we've got that little rule that I told you where 1%, a 1% solution is the same thing as a 10,000 part per million solution. So we can use that to get this out of being a percent and over to a milligram per liter type calculation that we know how to do. So bonsai is a 0.4% active ingredient solution, or it contains 0.4% paclobutrazole. Okay? So let's say what we want is we want to make 100 liters. We figure out we're going to spray this as a spray, and based on what we're doing over the certain area, for example, maybe we're doing it as a 2 quart per or 2 liter per certain area volume, but we work out that we need 100 liters to cover this area that we're going to spray. And we want to apply that as a 15 ppm solution, or 15 parts per million bonsai solution. Now, repeating myself, what we mean by that is not that we want 15 parts per million bonsai, but we want 15 parts per million of the active ingredient, AI, which in this case is paclobutrazole. Okay? So in this solution, we know that bonsai is an 0.4%, has 0.4% active ingredient, or AI. Okay? Again, we don't know how to use that, but we use the rule that 1% is equal to 10,000 parts per million. So if it's 0.4, we just multiply the 0.4 times, because 1 is 10,000, so 0.4 times 10,000 ppm means that solution is, another way to describe it is that it's 4,000 parts per million active ingredient. So we just took the percent active ingredient times 10,000 to turn it into a ppm thing. So another way to look at that is bonsai is also 4,000 parts per million active ingredient, or 4,000, it's a 4,000 ppm paclobutrazole solution. Now let's do a little converting on this then. You already done this. If it's 4,000 ppm, that also means that it's 4,000, by definition, milligrams of the active ingredient, and I'm writing AI because I don't feel like spelling out paclobutrazol, which is what the active ingredient is all the time. So by definition, 4,000 ppm is 4,000 milligrams of the active ingredient per liter. Dividing that by 1,000, just to kind of make these numbers a little smaller, it would be the same as being 4 milligrams AI per milliliter. We've really done no math. We're just converting these things, that what was on the label, into a usable form that we know how to do a calculation with. So that bottle of Bonsai, inside, it has 4,000 milligrams of the active ingredient per liter of that solution, or it has 4 milligrams active ingredient in every milliliter. This is now something we actually know how to measure out. So if we want, going back to our problem, and I'm going to switch pieces of paper here for you. Going back to what we wanted a 15 part per million solution. The 15 ppm also means 15 milligrams AI per liter is what we want. Well, we just determined in those calculations that 4 milligrams AI exist per mil of what's in that Bonsai bottle. So we divide these two, and these units cancel out. These will flip. And let me do my math here for you. Oops, so 15 divided by the 4 means we get 3.75. We would need 3.75 mils of Bonsai. Now we're talking the solution per liter of final solution. So in other words, we need 15 milligrams of active ingredient for every liter of final solution we make. We're getting 4 milligrams of the active ingredient in every mil of Bonsai. So we just divide them. So in order to get 15 milligrams, we need 3.75 milliliters of the Bonsai for every liter of solution. But we're making 100 liters, right? So we multiply that, and then these cancel out, and that means we need 375 mils of Bonsai added to our total 100 liters. So actually, you would basically have 99.625 liters of water plus the 375 milliliters of Bonsai added together. And that would give you 100 liters of solution. That would be a 15 part per million paclobutrazol solution using Bonsai.